All right, all I've talked about so far sounds great, right? It seems like we can go down into rock layers, into the stratigraphic record, and figure out exactly what the Earth was like in the past, right? It's like reading a history book. All the information is there for us, right? Well, not quite, right? And that's because not all information is preserved in the stratigraphic record. Just like not every organism was preserved into a fossil, not every period of time is represented in the stratigraphic record, right? And where time is not represented in the stratigraphic record, we call this an unconformity. Unconformities, I think of them as pages being ripped out of a history book, right? So maybe the Earth was laying down layers, pages were being written in that history book, and then for some period of time, there was an erosional event, and those history chapters, those rock layers were ripped out, eroded out of the history book, which means they're no longer there for us to read them, for us to interpret them. Right? Or maybe the author just got tired and stopped writing for a little while, right? Maybe for some reason there just wasn't any sediment or rocks deposited for a little while in Earth's history, right? So again, there's that missing time period in Earth's history book. That is an unconformity. So an unconformity is a gap in time. All right, so we're going back to the Grand Canyon diagram here. Where do you see an unconformity? Where does it look like there has been some erosion between layers of deposition? Right? You might notice this boundary right here, where beneath the boundary, the layers have been tilted. Above the boundary, the layers are flat, right? And that doesn't really make sense if you think about how layers are deposited. It must be that the layers that were deposited first flat and then angled were eroded down so that they become flat, or a flat boundary, before more flat layers were deposited above them. So anytime you see layers at two different angles that meet each other at a boundary, that's an unconformity. That's showing some sort of erosion there. The next unconformity you can see is in between the granite and the metamorphics. Right? Anytime there's a rock that is not sedimentary, either igneous or metamorphic, we can assume that those rocks don't obey the principles of stratigraphy. Only sedimentary rocks normally do. So anytime you see a boundary between igneous and metamorphic, we can assume that that's an unconformity, right? That's not representing time accurately. We can't use the principles of stratigraphy to interpret a rock that is not sedimentary.